Today, let's prove an inequality, a problem from the internet, MathLink. So here's my motivation. So as soon as I see this term, square root of n plus 1 minus square root of n, so it reminds me of a problem which I did when I first started learning calculus. That is, so square root of n plus 1 minus square root of n, find its limit as n approaches infinity. So here's the trick. So we multiply both the top and bottom by its conjugate. That is square root of n plus 1 plus square root of n. All right, so by doing so, we immediately have a difference of perfect square. Right? That is this square minus this square. Down here we have this sum of two roots, right? But up here we just have one. N cancels out. So that's how we know by using squeeze theorem. So this approaches zero. Right? So here's our motivation. So perhaps we can do the same thing. So all we have to do is to rationalize the numerator, meaning multiply by this conjugate. So I can first of all, so that 4n plus 2 can rewrite it as minus, this becomes plus. All right, that's the middle expression. So again, rationalize the numerator. All right, first I'll copy it down. Then multiply by its conjugate. So 4n plus 2 plus square root of n. Right, we do the same thing. 4n plus 2 plus square root of n plus 1 plus square root of n. Now, on the top here, immediately we have a difference of perfect square. Right? That is this square minus this square. But down here we still have this. Now, down here, let's copy it down, this one, plus square root of n plus 1 plus square root of n. Up here we have 4n plus 2 minus that square. Right, but this square is a little bit complicated. First of all, we have n plus 1. Then we have n. Then we have twice of square root of n times n plus 1. That's what we have up here. Right? So still we copy down this one. Right, but up here we have 4n minus 2n, we have 2n, plus 2 minus 1, we have plus 1. And we still have minus 2 square root of n times n plus 1. Right? So here looks like we can rationalize the numerator once again. Right? I'll just by doing this. Like I said, multiply its conjugate. Right? That is 2n plus 1 plus. Right? That is still 2n plus this one. Now, here what we have. top here we have this square minus this square. Right? This square. But this square is 4n squared plus 4n plus 1. This square becomes, you have minus 4 times n plus 1. Right? But that minus 4n squared, they can just cancel out. Right? Then you have minus 4n, right? Minus 4n, here you have plus 4n, so this is completely gone. All you have is 1, right? Down here, we copy it down, right? But before we copy it down, we can even say that let's just loosen the inequality a little bit. I make it a little bit bigger. Now everything is positive. We can just by making the bottom smaller, right? So before I copy it down, I say I don't even need plus 2, plus 1. Get rid of them, right? To make it smaller down the bottom. So here, I don't even need 1 here. I don't even need plus 1 here either, right? Because one thing I notice is that the degree, the leading degree of the polynomial of the function in terms of n, the degree is what? You have a square root, you have n, right? Looks like the degree is 3 over 2, right? So I can get rid of the 1, get rid of 1, get rid of 2, right? Because if I keep the 1 in a worst case scenario, 1 times this whole term, but this whole term leading power is half. It won't impact the whole degree, right? So I can copy this down. I get rid of this one, get rid of this plus 1, right? So get rid of this plus 1, we have n times n squared, 2n down here, right? So this top is 1. This actually becomes 2 square root of n plus 2 square root of n, 4 square root of n, 4n. Right? That's exactly 1 over 16 n times square root of n. So exactly what we desire. At the same time, it's of course remember, before I loosen the inequality, I still have 1 at the top. At the bottom, I still have positive.